Welcome to C++ for Engineers. This will be our first program, and the IDE we're going to use for this program is Microsoft Visual Studio. We will start our program by creating the classic Helloworld program. Every program written in a language has to come into existence, and the Hello World program is the way things have been done since about 1970. So I will open Microsoft Visual Studio. I want to create a new project. I want to create an empty project. Click Next. I want to call this project Hello World. Now I'm going to append a number 5 to it because I've made a few of these in the past. And I want to ensure all my projects go into a particular project directory. If we look here, we can see I'm having everything go into my OneDrive folder. So I'm just going to cancel out of this, and it's OneDrive projects. This is the name of my project. I click create, and I wait a moment, and I have the IDE, the Integrated Developers Environment, open. Right now it has nothing in it. This is my Explorer window to tell me the project. Here's the name of the project. Right now, it doesn't have any files I created. So let's create our first file. If you right-click Source Files and click Add, we're going to add a new item. We want to ensure it's a C++ file. Let's call this program or file main. That is the name we usually use for our main program. Now, the first thing we're going to need to do is to include any files. We'll talk about includes, and you can read about includes in the Zybooks. We want to include IO. And notice how the IDE is giving me suggestions. I want to include iomanip. This is one thing that is needed for every program. So I'm just going to highlight iomanip, press enter, and it's already filled out for me. Now the other thing I want to do to make my life easier is this term called using namespace. Using namespace, namespace, I forgot to highlight it, using namespace standard. This gives me certain shortcuts that I will be able to use. And then I want to create my main function. All functions include a return type int. We call this main, and be sure it's in lowercase. Just add these parens. I'll explain them in a later date. And now we include curly braces. Curly braces tell us that we're starting something new, and this is where we end. So the main program, after the word main and the parentheses, starts with the curly braces and ends with the end curly brace. Every main program will have a return. And we're going to return the number 0. Just know at this point that 0 means everything occurred successfully. Now, I'm going to comment out this using namespace right now. So the only thing we want to do is to exclaim hello world. The way we do that is by using the command cout. Just know that cout stands for console output. And I clicked the wrong button here. Let me close this. Cout, and you want to have two less than signs. And we want to quote, and we want to say hello world. And with an exclamation point. I will use the term bang for exclamation point because bang is a lot easier to say. So I'm going to print out the string hello world followed by a carriage return. A carriage return is also known as a new line, which just means we're going to go to the next blank line. And we signify that by saying endl. Now, notice I have a red squiggly under here. That means I have an error. Let's compile. The way you compile is you just click up here. It's going to tell me I have something wrong. I have errors. So it says I have errors here. Cout is undefined and L is undefined. When you are debugging, you always want to start with the first error that is disclosed. So if we double click on the line with the error, we go to where the error is in the program. Notice we have red squigglies under cout and L. That is signifying the error. If we click on the first error, you should always start on the first error. Actually double click it. You're going to go to where the error is. Now I know what the error is on this. Well, I actually have more than one error here. So iomanip is something that we're not going to be using for this. Every program requires iostream. I was incorrect earlier. It's iostream that every, and if I spell that right, every program needs. Notice this is okay now. Now, cout still has a red squiggly. So this shortcut that using namespace standard does, it allows me to not have to do what I'm going to do now. If I say std colon for standard, that red squiggly should go away, and an std colon and an L. Now let's recompile this and see what happens. Notice I still have the error. I have to include double colons here. Now the red squigglies go away. Now when I want to run, I click this again, and this will launch what's known as the debugger. Click it, it's going to run, and we get our output, and the output says hello world, and this is at endl. It's a blank line. The endl shows up. I'm going to close this window and we're going to talk about this for a minute. Like I said, every program requires this iostream. Include says go to the library. Basically, if you imagine a library in the world, you check out books. Well, we're going to the library, we're going to check out this program called iostream. So we're going to check out iostream, and this gives us certain things that we don't have to write in our program. One of them is a whole bunch of stuff that enables us to write software programs. One of these is a package of materials called standard. Well, in standard, there's this function called cout. Cout, like I said, stands for console output. Then the using namespace standard is a shortcut. So if I remove this double slash here, which stands for comment, this is a comment. If I remove that and make a comment, everything should still work, which it does. However, the shortcut I can take now is I don't have to specify the standard in front of stout or in front of endl. So we want to make our lives a little easier, because we all want to be as efficient as we can be. Now, if I run the program, everything will work again as planned. And I hit return or enter key. So let's talk about this more. That's what using namespace standard means. The semcon means I'm at an end of a statement. Okay, this first one does not need a semicon because that is not really part of C++. That's called a compiler directive, and the pound sign there says I'm a directive. I'm not part of C++. Here I am part of C++. Using namespace standard, I have to include a semicolon. If I don't include a semicolon, then my red squiggly shows up. So I'm going to include that semicolon back. And then I have my main program. Every C++ program has this function called main, and it is always in lowercase. And you have open and close parens, then you have curly braces. These curly braces say I'm starting my main program and I'm finishing my main program. Every main program should return a 0 on success. So I'm only printing out one thing. I am successful. I'm going to return a 0. Now the meat of the program is right here. Cout stands for console output. I include these double less than signs to say print this string to console output. So print the string hello world to the console output, followed by the endl character, which actually is a new line or a carriage return or a blank line added after hello world. So when we run this, like I said, we see our hello world followed by a blank line. Okay, I'm going to talk about a different topic now that requires me to add some lines to this program. We'll learn about ints and doubles and everything in future programs, but right now I'm just going to type in int, which stands for integer, num equals 5. So I'm setting a variable called num equal to 5 and int result equals 0 equals 0 and result equals num times 12. Cout result equals result. And notice result is coming up in my list here because the IDE is giving me a shortcut and thinks it knows what I want. So result, and let's follow that by an endl. Now I have some more code I added to my main function. I initialize a variable called num to 5. I initialize a variable called result to 0. I set the contents of result equal to num times 5. So after this after 9 line executes, I should have 60 in it. I print out the result equals and what's currently in the result, so hopefully that's 60, followed by an indel, followed by hello world. Now prior to this, I've just clicked local Windows debug, and I get this nice thing. Of course it says result equals 60, hello world. Now if you know your problem, if you know your project is working, you could always hit Control F5. That just runs your program. And see how it's a little quicker. So I have result equals 60 in my hello world. Notice it also exited with code 0. Code 0 happens to be this return statement, return of 0. That means that everything was successful. Now, what is the difference between Control F5 and debugger? Well, the debugger allows you to quote debug your code, and I can set breakpoints in my code. This is just a piece of information at the tip of the iceberg on debugging, but I can set breakpoints. See this gray area here? I can set a breakpoint here. Let's set it right before executing line 9. So when I run the debugger, it'll execute line 7, or execute all lines above, and then line 7, 8, and then stop before executing line 9. Let's start the debugger. So notice down here in my window down here, I see that number, or num, currently has a 5 in it, and my result currently has a 0 in it. And it tells me they are both integers. Now result currently has a 0 in it because I have not executed this line yet. So let's say something was screwing up. Set breakpoints and your program will stop. And then the other commands up here, step into is going to be used at a later date. Step over means go to the next line. Step out, I'll be discussing at a later date. So let's do a step over, which just means go to the next line. And notice down here, my result now changed to 60. I can hover over it and it tells me it's 60. Now my cursor is right here, which means I have not executed this line yet. Notice my output window currently is blank. When I execute, when I do another step over, I should have output in my window, which I do, result equals 60. If I do another step over, I should have some more data. And then when I do the return, do another step over, and we can see we're at the end of the program. We are not yet finished, so I could do one more step over, and now we're at the end of our program. Look at our window. Here is the end of the program, and again I exited with code 0. So let's say there was a mistake somewhere. You would set breakpoints to stop your code to look at what your results are before going on, and debugging is a major part of programming. This will conclude the first video on programming.